3.8. Canary releases, incremental exposure and risk mitigation. Blue-green deployments solve one huge fear. What if the new version breaks everything? We keep two worlds, switch between them, and rollback becomes easy. But after some time, another realization appears. Switching entire traffic at once is still a big moment. Even if we can flip back, we still expose everyone to the new version at the same time. And real systems have a cruel habit. Some bugs only show up under very specific traffic patterns, datasets, or user behaviors. So one team decided to change the shape of risk, and they asked, what if, instead of flipping everyone at once, we let just a tiny group experience the new version first? Not VIP users, not test accounts. Real users, real traffic, real life. But, and this is important, only a small percentage, 1%, maybe even less. The new version went live, but only for that little slice of the population. Everyone else continued using the stable version without even knowing there was an experiment happening beside them. The team watched quietly. They didn't stare only at dashboards. They watched outcomes. Are errors rising? Do response times look different? Do users behave strangely, abandoning flows they normally complete? If everything looked healthy, they nudged the dial upward. 1% became 5%, 5% became 10%, 10% became 25%. Not by emotion, by evidence. At any point, if signals looked wrong, the rule was simple. Stop, roll back the canary, investigate. The rest of the users never felt it. The impact stayed incredibly small. And now the name makes sense. In the old days, miners used to carry a tiny canary bird into coal mines. If dangerous gas appeared, the bird, far more sensitive than humans, would react first. The bird was not the goal. It was the warning system. In software, the canary release plays the same role. A small, intentionally limited group meets the new version first. If it thrives, the rollout continues. If it struggles, the system retreats before harm spreads. No drama, no system-wide outage, no hope this works. Just controlled exposure. Over time, the team noticed something subtle changing. Deployment conversations became calmer. Instead of asking, "Is this safe?" they began asking, how small should the first wave be? Risk wasn't eliminated, it was tamed. And perhaps the most powerful lesson emerged. We don't have to trust new code blindly. We can observe it in the real world, while the stakes are still small. Canary releases don't compete with blue-green. In fact, they often work together. Blue-green gives you the safe switch. Canary decides how fast you walk toward that switch. One manages reversibility. The other manages exposure. Together, they turn deployment from a leap into a careful, measurable, controlled progression. Canary releases in practice. How teams actually do it. In theory, canary releases sound simple. Give the new version to a small group first, watch it, then expand. In reality, success depends on one thing: the ability to control and observe traffic precisely. So let's walk through how teams normally implement it. Step 1. Two versions live at the same time. Unlike blue-green, where only one world is active at a time, Canary requires both versions running side by side. Version A is stable, version B is the candidate. They serve the same APIs, same endpoints, but to different slices of traffic. The key rule is, users should not know which version they hit, and switching should not break their session. This immediately teaches an important constraint. Canary works best when services are stateless or backward compatible. If a user switches between versions and something breaks, that's not Canary. That's accidental chaos. Step 2. Traffic is intentionally shaped. Someone or something decides 1% of traffic goes to the new version, 99% stays on the old one. Who makes that decision? Usually a gateway or load balancer at the edge of the system. Not because it is fancy, but because it sees every request. The rule is simple but powerful. Send this user to the new version. Keep everyone else on the old version. Sometimes it's random sampling. Sometimes it's based on headers, user groups, or geography. But the spirit is always the same: expose carefully, widen gradually. Step 3. Measurement matters more than opinion. Canary is useless if nobody watches it intelligently. Teams don't just ask, is it running? They ask, are error rates higher for Canary users? Are requests slower? Are retries increasing? Are users abandoning flows they normally complete? Do memory/CPU patterns look different? This is the moment observability meets deployment strategy. A mature team doesn't wait for users to complain. They let SLIs be the judge. If numbers drift in the wrong direction, roll back while the blast radius is still tiny. Where tools come in. Not magic, just automation. Let's connect concepts to real systems: API gateways and edge routers, the traffic knob. In many architectures, the canary switch lives at the edge. Think of systems like API gateways, service meshes, reverse proxies. They all do the same essential job: route X% of incoming requests to version B, the rest to version A. Teams love this pattern because it is reversible, to precise, and consistent for users, sticky routing when needed. The gateway becomes the dial. Turn it slowly, watch carefully, pause if needed. Kubernetes and Canary as a first-class behavior. Kubernetes doesn't just run containers. It gives structure to progressive delivery. You might deploy two versions of the same service, app v1, app v2, and then define rules describing send a tiny fraction to v2 first. Service meshes like Istio/Linkerd/etc. integrate with Kubernetes to handle percentage-based routing, health awareness, retries, and graceful rollback. Not because Kubernetes is cool, but because it makes two versions at once. Plus controlled traffic. Practical instead of painful. Feature flags. Canaries without redeploying. There's another clever twist. Sometimes teams don't split traffic at the infrastructure layer. They split behavior inside the app. Feature flags let engineers say, this feature exists in the code, but only 2% of users see it. If something misbehaves, they don't redeploy. They simply turn the flag off. This approach shines when UI flows change, pricing experiments happen, risky new behaviors are introduced gradually. The canary is no longer a server. It is a feature quietly entering the world. The quiet rule behind all canaries. Every successful canary rollout follows the same rhythm. Release, then observe, then decide, then either expand or retreat. No rushing and no guessing, no ego. And when teams do it long enough, something shifts culturally. Deployments stop being events. They become experiments, controlled, reversible, humane. Not everything needs a canary. Not every system supports it easily. But when risk is high and user impact would be painful, canary releases give time room to do its job, reveal truth slowly. When interviewers ask about canary releases, they're not just asking whether you know the term. They want to see whether you understand why it exists and when to use it. A weak answer sounds like, a canary release means rolling out to a small group first. True, but incomplete. A stronger answer is closer to this. Canary releasing lets us expose a new version to a small percentage of real users first. We compare SLIs, error rates, latency, completion rates, between canary traffic and normal traffic. If things look healthy, we gradually increase exposure. If metrics degrade, we stop and roll back before most users ever feel it. That answer shows awareness of risk control, understanding of metrics-driven rollout, focus on user impact, not just code. Great candidates also mention fit versus trade-offs. Canaries work best when services are backward compatible and relatively stateless. They require good observability, otherwise you're just guessing. We don't use them everywhere, but for high-risk features, they reduce blast radius dramatically. This tells the interviewer something critical. You don't treat tools as magic. You treat them as strategies chosen intentionally. And the real sign of maturity? Candidates shift from prevent failure to assume failures happen. and design rollouts so failure stays small. That mindset is exactly what senior teams look for. Once teams learn to release gradually, to let change arrive in small controlled waves, another realization eventually surfaces, even with careful rollouts. What if something goes wrong beyond our control? Not a bad deploy, not a slow feature, but things like data center outages, corrupted data, regional failures, disasters that remove entire environments from the map. At that point, the question shifts from how do we introduce change safely to how do we recover when the entire system is knocked off balance? And that line of thinking leads directly into our next chapter: disaster recovery and backup strategy, understanding RPO, RTO, and how systems survive the truly bad days. End of 3.8.